Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the derivative of these functions from first principles. So let's start with the function on the left side. The given function is y equals 6 minus 7x. So the first step is to write the expression for finding the derivative from first principles. Limit h approaches 0 and f at x plus h minus f at x over h. F at x is the given function, which is 6 minus 7x. So I'll write it here. So f at x is the given function 6 minus 7x. And now we can find the expression for f at x plus h by subbing in x as x plus h in the given function. So 6 minus 7 times x plus h. Now we can simplify this expression by distributing negative 7 into the parentheses. So we get 6 minus 7x minus 7h. Now we can use these expressions in this limit setup. So limit h approaches 0. So we get 6 minus 7x minus 7h, then minus f at x, which is 6 minus 7x over h. We cannot do the substitution for h as 0 because that will make the denominator 0. So first we'll have to simplify the numerator by distributing the negative sign in the parentheses. So we get limit h approaches 0. So then 6 minus 7x minus 7h minus 6 plus 7x over h. Now we can combine like terms in the numerator. So we can cancel out 6 and negative 6 and then negative 7x and plus 7x. So we are left with limit h approaches 0 minus 7h over h. So now we can cancel out the h's and now we have just negative 7, and since there is no h remaining in this expression, so the final answer should be just negative 7, because when we apply the limit there is no change because there is no h left in the expression. So this should be the final answer for the first function. Now we can analyze the second function. We'll start with the expression for the derivative from first principles. Limit h approaches 0. So f at x plus h minus f at f at x over h. Now here f at x is this given function. So f at x is equal to x plus 1 over x minus 1. And now f at x plus h will be, so we'll just substitute x with x plus h. So x plus h plus 1 in the numerator and then x plus h minus 1 in the denominator. And now we can substitute these expressions. So we get limit h approaches 0. So x plus h plus 1 over x plus h minus 1, then minus f at x, which is x plus 1 over x minus 1 over the whole thing h. Now we cannot do the substitution for h because that will make the denominator 0. So we'll have to subtract the fractions in the numerator, and for that we'll have to find a common denominator. So we'll multiply the first fraction by x minus 1 in the numerator and denominator. And we'll multiply the second fraction by x plus h minus 1, and then in the numerator and denominator. So we get limit h approaches 0. So in the numerator we get x plus h plus 1 times x minus 1 over x plus h minus 1 times x minus 1. Then minus, so in the second fraction we get x plus 1 times x plus h minus 1 over, and in the denominator we get x minus 1 times x plus h minus 1 over h. Now both fractions have the same denominator, it's just that the factors are in different orders, but in multiplication order doesn't matter. So we can combine the fractions and distribute the terms in the numerator. So we get limit h approaches 0. So when we distribute the terms, so we do x times x, then x times negative 1, then we do the same thing for h, and then we do the same thing for 1. So we get x squared minus x plus hx minus h plus then 1 times x, which is x, and then 1 times negative 1 minus 1. Now minus, now we'll do the same thing for the other pair of parentheses. So x times x, then x times h, then x times negative 1, then 1 times x, and 1 times h, and 1 times negative 1. So we get x squared plus hx minus x, then plus 1 times x, which is x, then plus h, and then minus 1 over, so the common denominator, which is x plus h minus 1 times x minus 1 over the whole thing h. Now we can simplify the expression in the numerator. So in the numerator, the negative x and positive x will cancel each other. Similarly, in the parentheses, the negative x and positive x will cancel each other out. So now we can rewrite the expression here. So limit h approaches 0. So we get x squared plus hx minus h minus 1. And now we can also distribute this negative sign into the parentheses. So that will change the sign of all terms in the parentheses. And then we get negative x squared, negative hx minus h, and then plus 1 over the common denominator x plus h minus 1 times x minus 1 over h. So we can simplify the numerator. So the x squares will cancel each other out. Hx and hx will cancel each other out. Negative 1 and positive 1 will cancel each other out. So we get limit h approaches 0. So in the numerator we just have negative h minus h, which is equal to negative 2h over x plus h minus 1 times x minus 1. Now in order to rationalize this expression, we can write it as a division statement divided by h. And now we can change this into a multiplication statement. So we get negative 2h over x plus h minus 1 times x minus 1 times 1 over h. So we flip the fraction after the division sign. So h is basically h over 1. So now we can cancel out the h's in the numerator and the denominator. And we can also apply the limit. So we sub in h as 0. So we just get negative 2 over x plus 0 minus 1 times x minus 1. So the 0 goes away. So we are left with just 2 over x minus 1, x minus 1, which can be simplified to just negative 2 over x minus 1 squared. So this should be the final answer for the derivative of this given function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.